Okay, so just wanted to say a few words in response to the LinkedIn challenge that I posted at the beginning of last week. Massive amount of feedback, lots of comments, lots of resharing, lots of engagement with the challenge. Obviously, I was focused on looking at the time it took to develop a Hex-Mesh for a complex solid. We had lots of people looking at different techniques, some people contacting me directly, some people posting videos to YouTube and referencing the links. There are examples using conventional FEA methods, using different types of mesh, people using meshless techniques with very fast results, and people looking at polynomial methods, again a pretty fast and robust method to get achievable results. Perhaps a little remiss of me to set the objective measure for the task, purely in terms of time. What I was trying to highlight was the capability within Apex to simplify solid geometry for hex meshing. Obviously, hex meshing can give massive reduction in terms of model build or node count and solve time compared with legacy methods, maybe using tetrahedral mesh techniques. So Apex for non-FEA users. Okay, so Apex is very easy to use, very easy to learn. Of course, we can build a tech mesh model and solve that in less than a minute with minimal user input or indeed user engagement. Really thinking about Apex, more about an FEA toolset that allows both quick design layered evaluation, maybe for non-FEA experts, but also a tool that works right through the product lifecycle. Many aspects where this becomes important. So for detailed FEA, for complex production analyses, maybe interfacing with legacy models, workflow automation, controlling meshes for convergence, and maybe result export for downstream applications. There's the ability to iterate design through optimized and exported geometry. So you can update your model, rerun the analysis very quickly, and then export the data back into the CAD environment for a detailed design development. We've got the ability to interface with other industry standard solvers, whether that's from an FEA approach using something like MSC Nastran, or for multi-body dynamics type simulations whereby you want to look at stiffness matrix and how that interfaces with the rest of the dynamic solution. So given the really positive response we've had to this challenge, we've got another challenge coming up, which is looking at the shell mesh development for a complex aircraft rib. So in this case, the client was interested in particularly a shell mesh model and how that can interface with their legacy workflow and legacy model environment. So keep an eye out for that, and hopefully we'll get the same level of feedback, and really keen to understand how people get on with their own tool sets.